Hello students, welcome to IMS GATE Academy. We are going to discuss about different concepts on network theory. This session is only for the students who are going to appear for the GATE and other PSU exams. So in the last session I explained well about the nodal analysis, and also I have done certain number of the problems also. In today's session we are going to see well about the mesh analysis. I will explain what are the rules are employed in the mesh analysis, how to be done different types of problems. Certain simple problems initially I will do, then after I will give the what now? Good questions also then. So everybody will get good command on mesh analysis. Understand now? Okay, I will start now. Mesh analysis. Now directly we cannot enter into the mesh analysis. Initially students should understand what is KVL, Kirchhoff's voltage law. After knowing the KVL, we can do the mesh analysis now. Mesh equation how to be taken, that you can understand only if you know KVL. So here I wish to put initially KVL, Kirchhoff's voltage law. But the Kirchhoff's voltage law is defined in a closed path. KVL is, we are going to use only in the closed path. That is, loop or mesh is more important. Without mesh and loop we can't apply the KVL. That's why you can write one sentence now. The KVL, it is defined in a closed path. In a closed path, that is very important. That is, closed path means what? Loop or mesh. Loop or mesh is a must. Loop or mesh. I can put. What is that KVL? What is that voltage law? Suppose I have drawn a network in this way. There is a resistor R1. This is one more resistor R2. I connected with a battery. That battery voltage I have taken V. That is the battery voltage V only now. In this case, current is going to flow in this direction. Current is going to pass in this direction. I wish to take that current as I. What is that KVL? Says for any closed path, some of the voltage drops. This voltage drop I have taken V1. This voltage drop I want to take V2. When the current is passing this side, polarity is to be taken plus. Initially it is with high potential. Then when it comes out of this resistor, potential drop is possible there. It is reducing. We are going to put minus. The same way current direction this side is a plus, minus I can put. What it says, what this KVL says, for any closed path, the sum of the voltage drops across the resistors is equal to supply voltage. What is the meaning of this? Supply voltage is nothing but V. V equal to V1 plus V2 it says. I would like to write KVL in this way. For any closed path, sum of voltage drops across resistors across resistors is equal to supply voltage, that only KVL is equal to supply voltage. How we can write an equation? Supply voltage V equal to, I can write V1 plus V2. I can write V1 plus V2. So still I can write V1 is nothing but drop across this R1. What drop is possible? Current into resistance. Ohm's law is applicable. Current into resistance, I into R1 plus I into R2. That way I into R2 I can write here now. I into R2 is must. I into R2. That's possible here now. This is nothing but the KVL. Once again I am repeating. For any closed path, the sum of the voltage drop across resistors is equal to supply voltage. Sir, you can have a doubt there now. Sir, in a closed path, we need to have only resistors. No. Here I have taken the what no resistors. Even you have taken one is a resistor, one is a one inductor, third one is the capacitor. It is acceptable. It doesn't matter now. Understand now? Any element you can use. Any element RLC you can use only. Understand my point? That point is very important. Next. But one more point is very important now. Just I will write and I will explain now. The KVL is independent. The KVL is independent of nature of element, of the nature of element. I will explain of the nature of elements in a closed path. In a closed path, that point is very important. In a closed path or in a loop, also it is in a closed path or loop, any word is allowed. What is the meaning of this? The KVL is independent of the nature of the element. That means that the nature of element you can have linear, non-linear, active, passive elements, acceptable. So that is why they are independent of the what nature of the elements only now. It is not given any restriction. It must be this element. It must be that element. Linear. It must be non-linear. Not given now. It is independent of the nature of the elements only now in a closed path only. That's why that is linear, comma non-linear, otherwise active, otherwise passive, also possible. Anyone is acceptable, the element. It is not dependent upon these elements. Understand my point now. But how we can form the mesh equation? That is very important. Mesh equation or mesh analysis equal to, we can take now. Mesh analysis equal to, we can do by this way. Mesh analysis, how it is to be done? Mesh analysis or mesh equation, that equal to KVL plus Ohm's law is applicable. That point is very important. Ohm's law is applicable. By using this, mesh equation is to be formed. That's more and more important now. And what are the rules you need to adopt to do the what now? Any problem. That is one more important point. So I would like to give rules to apply mesh analysis. I will give rules for mesh analysis. To apply the mesh analysis, what are the rules you need to follow? That is very important. Initially, you must identify number of meshes are existing in the given circuit only now. How many number of meshes are existing? Otherwise, how many number of loops are existing? You identify at first. That's very, very important now. That's the first point we can say. Point number 1, identify number of meshes or loops. That is very, very important. How many number of the meshes are there, you identify, or how many number of loops are existing, you try to identify. Then assign the mesh currents in that particular loop or in that particular mesh. What I wish to say, point number 2, I can say assign the mesh currents. The mesh currents, very important. Assign the mesh currents. Assign the mesh currents. How to assign? You can take all are in clockwise, all are in anti-clockwise also acceptable. It doesn't matter now. The selection is your option. But all the currents to take in the clockwise direction or all the currents in the anti-clockwise direction. Choice is yours. Understand my point? Then the second point is required. Then after, what you have to do, rule number 3, initially you must apply the KVL and Ohm's law applicable second only now. I say point number 1, by using KVL first, initially we are going to apply the KVL and Ohm's law next. Ohm's law next. Write mesh equation. Write mesh equation, I can say. So these are all the rules you need to apply. What it says, when a problem is given or when a network is given in your hand, you need to identify at first how many number of loops are given, that you have to identify, or number of meshes are given, you must identify. That is the point number 1. Point number 2, you assign the mesh currents or loop currents, we can say. But how the direction of the currents are to be taken, that is the rule number 3. You can take all the currents in the clockwise direction. Otherwise, you can take all the currents in the anti-clockwise direction. Choice is yours. So these are the rules you need to apply to do the problems by using mesh analysis, I can say. But just 2 problems I will do, 2 or 3 problems, simple problem. Then after I will do the somewhat lengthy questions also. Understand? Question number 1. Determine the current I. Determine the current I asked. Current I want current I. And the network is a one single loop I gave it here now initially. It's a very simple question starting, anybody can do. So just to know the concept, initially I am giving this problem. Here it is given with 20 volts and also connected with 5 ohm resistance. One simple example only. Here connected with 5 volts. One simple question only now. 5 volts I gave it. This current is nothing but I gave it for example. That is I have taken now. But how you can measure this I? What you will do, how many number of loops are existing, you ask. One loop is possible, that is I only now. That current only I. We are going to put. And the polarity is more important. Bigger electrode given means plus, minus, plus, minus. When current is passing this side you put plus, minus you put no. Apply the KVL and Ohm's law is applicable. Minus 20 here. When you go this side, plus 5 into I, plus 5 equal to 0, no doubts. And 5I equal to, we can write as a what now, 15, and I is nothing but 3 amperes possible. Just to know how to apply the KVL. One small problem I gave it. And one more question I will give now, one more simple question I will now try to do this now. Find current through 5 ohms. Find current through 5 ohms. Find current through 5 ohms. And here I gave 10 volts battery here. And here I connected the 5 ohms I connected here. Five ohms I have taken, and this side I connected with some voltage. That voltage I have taken minus and plus 5 volts I connected here. Find current passing through 5 ohms I want. How we can find? Any student can give answer for this question very directly. Can you give answer for this question? What current will pass across the resistor of 5 ohms? Anybody? Any student can do it? You should understand one point here now. Across the 5 ohms current, the current across the 5 ohms we cannot determine. The polarity of the batteries you was, here it is given with, it's a 2 voltages, 10 volts I gave it now. Some 10 volts, okay, 10 volts here, the 5 volts I gave it here now. But in this case, we can apply or not now. 10 volts and minus 5 volts is given this side. Here, the circuit does not exist only, we can say. We cannot apply the mesh analysis here now. Violation of the KVL is done in this particular problem only, we can say. When the resistance of the 5 ohm is connected here, catch my point. When the resistance of the 5 ohm is connected here, voltage across this 5 ohm must be constant value only required. 10 voltage is connected means 10 voltage drop is possible. This side also you must connect with a 10 voltage only. But the minus 5 you got now. One is a minus 5, one is a 10 voltage, impossible in the network. The voltage must be same required. In case this is a 10 voltage, this is also 10 voltage, if it is given directly we can say voltage across 5 ohm is nothing but the 10 ohms, 10 volts, and 10 by 5 is nothing but the 2 amperes of the current is going to flow. But in this case, we cannot find. The violation of the KVL is possible. How can you say violation of the KVL is possible? Whenever you are applying the KVL in this direction, in this particular branch, if it is taken the KVL, what happens? Minus 10. When I go this side, minus 10. I have taken the mesh this side. Minus 10, minus 5, that equal to 0 possible. And I am going to get minus 15 equal to 0. How it is possible? Minus 15 equal to 0 is impossible. 0 equal to 0 possible. Minus 15 equal to minus 15 is possible. Here violation of what? KVL is done. That's where you can write now. Since the violation of the KVL in the circuit, since violation of KVL in this circuit, since the violation of the KVL in this circuit, current through 5 ohm doesn't exist now. That means physical connection is not proper only, you can say. The connection is not proper only now, we can say. The physical connection of network is improper. This is improper only. Improper it is connected. That's why what is an answer we can say? It doesn't exist current across this 5 ohm. What doesn't exist? The circuit doesn't exist at first. That's why KVL is not applicable, means mesh analysis we can't use. Current also not possible to get only, we can say. I will go to the next question now. I want to give one more question here now in your hand. The next problem. Find current passing through. Find current passing through. Current passing through. Find current passing through 50 volts source, 50 volts source it is given. And how that network is given, you please watch. Here connected with 5 volts, 5 ohms this side. This is given 5 ohm resistor. And there is a battery plus minus. This is connected with 50 volts. This is with 50 volts. And this side here the current source is connected this side. There is a current source. The current is given 10 amperes. This is connected with 10 amperes. And this side it is connected with 2 ohm resistor. This is a 2 ohm resistor is connected. This side. This is a 2 ohm resistor. And also here connected with one more resistance of 3 ohms. Resistance of 3 ohms and connected with 10 volts. Connected with 10 volts, I can say. In this way, the connection is made. This is the given problem. I am checking the values once again, 50 volts and 5 ohms and 10 amperes and 2 ohms and 3 ohms and 10 volts it is connected. Yes, this is correct. But he is asking to measure current passing through this 50 volts. What way we can do? When the network is given such a way, we need to redraw this network in a still simple way. After that, we can start our work. The current source is given here now, 50 volts and 5 ohms are connected. These two I want to connect as it is. I say, I connected here 5 ohm. Otherwise, I will draw in the next page best. I will draw it in the next place. The 50 volts and 5 volts here connected now. 5 ohms here connected. Yes, I will connect 5 ohms. And also connected with 50 volts here. Plus minus and 50 volts here connected. To the first arrangement of the network. And also what is given here now, 10 amperes connected parallel to the 2 ohms. These two nodes we can combine, 2 ohms and 10 amperes are connected in parallel. Their applicable source transformation. The current source to convert into the voltage source. How we can connect, how we can draw that network. The source transformation I want to apply 10 into 2, 20 volts I can get. 20 volts in series to the 2 ohms it is possible. 10 into 2, 20 volts it is possible. I will connect here now 20 volts with a resistor. And they are given 20 volts this side. Plus minus I can put. What resistance is given here now? Please check it. The resistance of 2 ohms here connected now. That must be connected in series. That must be connected in series. There is a 2 ohm only. The rest of elements must be drawn as it is. I say, what are the rest of elements we are having here now? The rest of elements here we are having 3 ohms and 10 volts. 3 ohms and 10 volts. 3 ohms and also here we got 10 volts. This is 10 volts we got. 3 ohms and 10 volts. Yes, correct. Such a way the network is formed. Now it is very simple to find current which is passing through the what now 50 volts here now. I can apply directly how many number of loops are existing in the given circuit you identify. How many loops? 3 loops, 2 loops are existing. The current passing through this loop I wish to take it as a I1. That loop current I want to take I1 because the mesh analysis I want to apply. And the current which is passing through the second loop I want to take I2. I selected these two currents in clockwise direction. Choice is yours. I don't want clockwise or I will take anti-clockwise. Your choice will be now. But how we can form the mesh equation? I will apply the KVL in this direction. When I go this side minus 50, I will put minus 50. When you go this side, some drop is possible. 5 into I1. 5 into I1 is possible. When you go this side, 2 into the current which is passing through the 2 ohms is nothing but the difference of these two currents only. I1 is passing this side means I2 will pass in reverse direction. When you consider this loop, you must take I1 minus I2. When you consider this loop, I2 minus I1 is more important. I wish to say here the plus 2 into what current is passing this side? I1 minus I2. I1 minus I2. When you go this side, plus 20 is possible. Plus 20, that equal to 0 possible. That equal to 0. There you can add what I1 is possible. 5I1, 2I1, 7I1 I can write. What about I2? I got the minus 2I2. And minus 50 plus 20 means it is a minus 30. When it goes to this side 30 is possible. This I want to take it as equation number 1. How many number of equations I can form? How many mesh equations we can form? Means 2 mesh equations we can form. By using the first loop, I formed first mesh equation only now. Now 7I1 minus 2I2 equal to 30 is correct now. And what about the second equation? Second equation, this mesh I want to take. This loop current I want to take now. When you go this side, 3 into I2 I can note down. 3 into I2. When you go this side, plus 10 volts here possible. Plus 10. When I go this side, minus 20 volts here possible. When I go top, 2 into what? This loop is considered means I2 minus I1 is more important. I2 minus I1, that equal to 0. I am repeating once again, whenever this loop is taken, 3 into I2 is possible, plus 10 is possible, minus 20 is possible, 2 into I2 minus I1. We can simplify this now. What I1 is possible? Minus 2I1 is possible here. Minus 2I1 is possible. What about I2? 3I2 plus 2I2, 5I2 I can write here now. 10 minus 20 minus 10, when you brought this side, plus 10 I can get now. This I want to take it as equation number 2. This is the second mesh equation we got from the given circuit, this one. But whenever you are solving these equation, you will get the I1 and I2. But you solve it, I will give directly value. I1, whenever you are solving I1 and I2, I1 comes as 5.48 amperes mostly positives. But the problem is asking to find current passing through the 50 volts. Current passing through the what now? This 50 voltage means what I can write now? Same I1 only it is going to pass. That's why we can write now current passing through 50 volt source. Directly I can write now current passing through 50 volts is what I can write 5.48 amperes it is possible. This is the solution by using the mesh analysis we got. And I will give you one more question, you please try. Next question. but I wish to give one more question. You please try this question without my help. Find the power loss in 10 ohms. Find the power loss. Find power loss in 10 ohm resistor. In 10 ohm resistor. In 10 ohm resistor in the network. In the network. But how that network is given, you please watch. This is given like this. There is a 10 ohm resistor here. This is a 10 ohm resistor. Here connected with a battery here. This is given with 15 volts. This is connected with 15 volts. And also connected one resistor 2 ohm. Resistance of 2 ohms here connected now. Here connected with 3 ohm resistance. This is 3 ohm resistance. And here connected with 8 ohm resistor. This is 8 ohm. And this side it is connected with 5 ohm resistance. This is 5 ohm resistance. And these are all connected like this. That's all. This is the given problem. I will check the values again. 15 volts and 8 ohms and 5 ohms and 3 ohms and connected 2 ohms and 10 ohms. Yes, that is the given problem. Anybody can find the current power loss in 10 ohm resistor. Power loss in 10 ohm resistor. The given element is nothing but resistor. In a resistor, the power loss is nothing but I square R, you know. Power consumption also we can write now. The power consumed across the resistor is nothing but I square R. What current is passing to the 10 ohm is more important now. The current passing to the 10 ohm, if you want to find, you can apply any method now. Here I want to apply the node mesh analysis only now, because today's session is with the concepts of mesh analysis only now. That is why thereby applied mesh analysis. How we can apply the mesh analysis here now? How many number of the loops are existing in the given problem you identify? This is one of the loop. This is one of the loop. This is the second loop. Third loop we are having now. 3 loops are existing. So I wish to select 3 loop currents in clockwise direction. And I wish to select this current as I1. This current as I1 I want to take. And current which is passing in this loop I want to select as I2. This current is nothing but I2 I can note out. But this is one of the loop connection 10 ohm and this side and go this side. I can take the current in this direction is nothing but I3 I can take. Which current is required from the given network? We are in need of I3. Once we know the current of I3, the power loss across 10 ohms we can determine very easily now. So by using the mesh analysis, you try to find I3. How many number of equations we can form? 3 equations are possible because we got the 3 loops only now. And I will find 3 equations and we can solve those equations easily now. How we can take means this loop I have taken at first. When I go this side, this is a minus, this is a plus, I can take here now. Minus 15, I can note down. Solution I want to take here now. Minus 15, when I go this side, drop across 8 ohm, the 8 is existing between this loop and this loop. 8 into I1 minus I3. Don't take I3 minus I1. Because whenever this loop is considered at first, this current minus other current you must take. So 8 into I1 minus I3 plus 8 into I1 minus I3 I can put here now. When you go this side, 3 into what current is passing across 3 ohms? I1 minus I2 I can put now. So plus 3 into I can write I1 minus I3. I1 minus I2 I can note down here now. 3 into I1 minus I2. So these are the elements that equal to 0 is possible here now. Catch my point. I started from here, minus 15 equal to 8 into I1 minus I3 plus 3 into what? I1 minus I2 equal to 0 I have taken now. Just expand and simplify it. What I1 is possible? 8 plus 3, 11 I1 I can get here now. What about I2? Minus 3 I2 is possible. What about I3? Minus 8 I3 is possible. 8 I3 is possible. That equal to 15 is possible. This I want to take it as equation number 1. Please check this. 11 I1 minus 3 I2 minus 8 I3 equal to 15 we got. That is taken as equation number 1. And by selecting this loop, one more mesh equations I can form, or loop equations I can form. How I can form? When I go this side, 2 into I2 is possible. 2 into I2. When I go this side, 3 into I2 minus I1 I can note down. Plus 3 into I2 minus I1 I can note down here. When you go this side, 5 into I2 minus I3 possible. Plus 5 into I2 minus I3 is possible. That equal to 0. We can note down. I am repeating 2 into I2 here plus 3 into I2 minus I1. This side 5 into I2 minus I3. We can simplify this. What I1 I can get? Minus 3 I1 I can get here. Minus 3 I1. What about I2? 5 I2 plus 3 I2, 8 I2. 8 plus 2, 10 I2 I can get here. What about I3? 1 I3 is there now, minus 5 I3 is possible. Minus 5 I3. Do you have any constant? We don't have any constant. If you don't have any constant, equal to 0, I can note down here now. Equal to 0, I can note down here now. So I can write this equal to 0. I wish to select this as an equation number 2. So can you form the third equation from the given network? From the given network. But how the third equation we can form this loop, I can consider. 10 into I3 is possible here. 10 into I3. I can note down 10 into I3. When I go this side, plus 5 into I3 minus I2. Plus 5 into, I can note down I3 minus I2. I3 minus I2. When I go this side, plus 8 into what? I3 minus I1 is possible. I3 minus I1 is possible. That equal to 0 is possible. That equal to 0. Then we can find, we can simplify this equation now. What I1 is possible? Minus 8 I1 I can get here. What about I2? Minus 5 I2 I can get here now. What about the I3? 10 I3 here, 8 I3 here, 8 plus 10, 18, 18 plus 5, 23 I3 is possible. 23 I3, that equal to 0 is possible. This I want to take it as equation number 3. You please solve and find what is I3 here. What I3 you can get. By using the Cramer's rule, you can find the I3 value. By using the Cramer's rule from the mathematics, you select and find the I3 value. Otherwise, directly you can solve. If you are solving these 3 equations, you can get I3 value. Directly I am giving here now. The value of I3 comes as I3 equal to 1.23 amperes. It comes 1.23 amperes you are going to get. Once you are getting the current of I3, you can determine power loss in 10 ohm resistor. The power loss across this 10 ohm resistor required. I can write power loss in what resistor is given? 10 ohms. Power loss in 10 ohm resistor. So power loss is nothing but I3 square into R. R is nothing but 10 ohm here. I3 is nothing but, we got to say 1.23 whole square. 1.23 whole square I get. And resistance R is given here, not 10 ohm. These are resistance R I have taken, 10. The value it comes as 15.13. 15.13 watts we can get now. That is the result is possible now. Such a way we can tackle this question now. I think students followed this question. Now I want to give one more question in your hand. You please try this. You please try this. The next question. The next question is, find current through 10 volts battery. Find current through 10 volts battery. 10 volts battery. But how the network is given, you see here now. The given network is 1 ampere current source is connected here. This is 1 ampere. And 2 ohm resistor is connected here. Here connected with 2 ohm resistor. This is with 2 ohms. And 1 ohm resistor is connected here. This is 1 ohm. And 2 ohm resistor is connected this side. This is 2 ohm. And 1 ohm is connected this side. This is 1 ohm. And also connected with one battery. That battery voltage is given here now 10 volts. Yes, this is the given problem. This is the given problem. That once again I will see the values here, that 1 ampere and 2 ohms and 1 ohm and 2 ohm and 1 ohm and 10. Yes, anybody can find. Is asking to find the current passing through the 10 volts battery. Current passing through this battery is required now. You please try this question. I will give some time. You please tackle this question with your own effort. With your own effort, you can do this question. What way we can find current through the 10 volts? But in the problem you check, current source is connected parallel to the 2 ohm. In that case, it is applicable source transformation. Once you apply the source transformation, the network you can simplify. After simplifying the networks, you can apply the mesh analysis now. By using the mesh analysis, you can find the current passing through the 10 volts very easily now. How I can do? I will draw the equivalent circuit again here now. How the equivalent circuit we can take? This can be drawn in this way. Current source is connected parallel to the 2 ohm. I will convert into the voltage source here now. What voltage? 2 into 1. Current into resistance is the voltage. And you must connect a resistor in series. These 2 ohms must be connected in series and must be connected with a voltage source. Current direction top, there is a plus minus possible. 1 into 2, 2 volts here possibles and 2 ohms. And also they are connected 1 ohm. The rest of circuit we can draw as it is. In the 2 ohm we got, that must be connected as it is. And this side we here connected with 1 ohm resistor and also connected with one battery. That voltage is given 10 volts. This is the given problem. 2 volts in series to the 2 ohm. 1 ohm here, 2 ohm here, 1 ohm and 10 volts. Now I want current passing through 10 volts. How many number of loops are existing in the circuit? You check it. 2 loops are possible. This is one of the loop, the second loop is possible. We can put the what now? We can assign the loop equation or mesh equations here now. I am putting the loop equation. This is I1. This I want to take it as I2. So I2 is nothing but current passing through 10 volts directly. The same problem you can do by using the what? Nodal analysis also. Here I don't want to discuss the nodal analysis because in the last class I did the questions by using the nodal also. But you will see shortly, sometimes in a problem it comes necessity to apply the nodal and also KVL also. When it comes, you will see the what now problem shortly. But anyhow, the current I2 is required in the problem. What way we can get? By selecting this loop, I can get now -2 here. When I go this side, drop across this, I can put 2I1. When I go this side, plus 1I1. When you go this side, 2 into what? Difference of these currents, I1 minus I2. That equal to 0, I can put directly. What I1 I can get? 2 plus 2, 4. 4 plus 1, I1. 5I1 I can get from this network. What about I2? 2I2 I got here now. -2 I2 I am getting. That equal to 2 is possible. This I want to take it as equation number 1. You try to form one more mesh equations from the given network. From the given network, you try to form. We got 5I1 minus 2I2 equal to 2. That is equation number 1. In the second equation, whenever you are going this side, 1 into I2 I can note down. 1 into I2, I2 only. Minus 10 I can take. When I go this side, 2 into I2 minus I1 I can put. 2 into I2 minus I1. That equal to 0 is possible. So when you simplify this, you will get equation in this way. -2I1 I can note down here. What I2 we got? 2 plus 1, 3I2 is possible here. 3I2 is possible. That equal to 10. This I want to take it as equation number 2. We got the second equation. We got the second equation by using the mesh analysis. By using the mesh analysis. So 2I1 minus 3I2 2 into I2, 2 into I2 we are getting here now, I2 we are getting minus 10 is possible. Yes, correct only now. Yes, to solve this now. By using this I2 you can measure what now? By using these two equations you can measure. What is I2? You calculate. Find I2. Because the current through 10 volts we want. Find I2. What I2 is possible? You calculate. Using calculator you can get answer. Mostly if you are calculating I2 value, it comes as a 4.91 amperes it comes now, 4.91. Anyone you solve, you will get I2 value. This is one of the question. And I will go to the next question again. I want to go to the next question. The next question is, find VI, is asking to find VI, input voltage I want. Find VI, I want input voltage. The network is given like this. There is a resistor and also with one source. This is with 10 volts here connected. The value of resistor is nothing but 4 ohms. Here VI is connected this side. This is VI. The polarity is given, this is a plus, this is a minus. And here connected with 2 ohm resistor and also connected with 3 amperes. Current of 3 amperes here connected. But I want here VI value. Can you find that VI value? Can you find, anybody can find VI value from the given problem? From the problem, can you find VI? Can you find VI from the given problem? But this problem is a very simple. The current of 3 amperes it is passing. This side, this is an open circuit only. That open circuit is given with VI voltage. When these two terminals are open, the 3 amperes will flow this side, same 3 amperes will try to flow this side also. Same 3 amperes it is going to pass in this direction. But when 3 amperes is passing this side, we can find easily voltage across this 3 into 4, 12 voltage we can get directly. This becomes a 12 voltage one. But in this case, I can measure the VI by applying the KVL in this direction. In this direction, we can apply the KVL. How we can take VI equal to, I can take directly. VI equal to, how we can get answer? VI equal to sum of the drops 12 plus 10. It becomes 22 volts mostly possible. That is the VI is possible. It's a very simple question. Anybody can do. 22 volts here possible. Next question, nodal analysis and KVL I will apply in the problem now. In the next question, you see how that question will be then. How that question will be, I will give. But in this problem it is given, find voltage across 8 amperes, find voltage across 8 amperes. Voltage across 8 amperes are required for the given problem. For the network is given like this. There is a current source. That current source is connected with 8 amperes. 2 ohm resistor is connected this side. And here connected 2 ohms. This is a 2 ohm. Here connected with 2 ohm resistance. Here connected with 16 volts. 16 volts. 16 volts possible. Mostly in the competitive exams or GATE exam, we cannot find necessity of applying the mesh analysis mostly. By using the nodal analysis, maximum number of students are going to complete any question now. To know how to use the mesh analysis, I am doing the what? No, certain number of the problem. The problem is a complex or very simple, that is not the matter now. The concept you can understand. The mesh analysis, how to apply for the given problems of different model. To know that, I am giving the explanation here now. But anyhow, here given 8 amperes, 2 ohms and 2 ohms, 2 and 16 volts here connected. Is asking to find voltage across this. The voltage across this is given V 8 amperes it is given. The polarity also here given, this when it goes this side, this must be a plus, this must be a minus, click Y. Anybody can find voltage across this 8 amperes current source? Anybody can find without my help? Anybody can find without my help? What way we can find? What way we can find voltage across this? But in this case, what I wish to say, the voltage across these 2 ohms at first you find. Voltage across 2 ohms you find. Voltage across 2 ohm is nothing but this node voltage itself. Voltage across 2 ohm is nothing but the B. Once if you know the voltage across this 2 ohm, directly you can apply the KVL in this direction. You can apply the KVL. By the application of the KVL, you can determine voltage across this 8 amperes current source. What I say here, initially that node voltage or voltage across the 2 ohms, if you want to find nodal analysis, you apply. After nodal analysis, I will apply the KVL to determine voltage across these 8 amperes. How that nodal is applicable, I explained already in the last session. Summation of the currents This means this current plus equal to 0 only. This current plus this current equal to 0. Away from the node, you can put directly. What current is passing this side means, 8 amperes in reverse direction. I can put the sign minus H. The current which passes this side is nothing but minus H. The current in this direction is nothing but V by 2. V by 2 I can write. The current which is passing this side is nothing but V minus 16. V minus 16 divided by 2. That equal to 0 I can write. That equal to 0 I can write. Summation of all the currents equal to 0 I have taken here now. Thereby applicable simplification. How I can apply the simplification? The 2 is LCM, 2 into 8, 16 plus V minus 16 equal to 0. Then I can write 2V equal to what? 32, this side 32. And finally, V equal to what? 16 volts, it is possible. We got voltage across this 2 ohm is nothing but the 16 volts. Now it is applicable KVL. By using the KVL, you can determine required value. Just apply the KVL. When you go this side, minus V of 8 amperes, voltage across the 8 amperes. When you go this side, drop across this 8 into 2, current of 8 amperes is passing, 8 into 2, 16 is possible, plus 16 volts, 8 into 2. When you go this side, voltage across 2 ohm is nothing but 16, plus 16 equal to 0. Then I can find what is voltage across 8 amperes, 16 plus 16, 32 volts it is possible. This is the voltage across this current source we can say now. That way we can calculate the required current I say. That is answer. The one more question I want to give in your hand. The next question is given here now. Find I. Is asking to find I. The network is given here. 1 ohm resistor here. Here connected with 1 volt. This is 1 volt. This is 1 volt. Here connected with 1 ohm. And here connected 1 ohm. This is also 1 ohm. And here connected with a voltage source, plus minus. That voltage is given 1 volt. Here connected with 1 ohm. This is 1 ohm. The I is nothing but this current is given I. Is asking to measure I. Can you get answer? Anybody can find answer for this question? The 1 ohm and 1 volt and 1 ohm and 1 ohm, 1 volt and 1 ohm is connected. Anybody can get answer for this question? What current is passing this side? But in this case, just by this current is a I means even this current also will become I, no doubt, everybody knows. Then I can determine by selecting this loop. This loop you connect, directly you can measure I. How we can find solution I can get in this way? 1 into I, when I go this side minus 1 volt, when I go this side 1 into I itself, when you go this side plus 1 is possible, when you go this side plus I is possible, that equal to 0. I plus I, 2I is possible, that equal to 2, so that equal to 0 only possibles. 2I equal to 0 means current I is nothing but the 0 amperes is possible. The finally what current is passing across this 1 ohm means directly we can say 0 amperes of the current is passing. Understand now? That much amount of the current is possible. So these are all the problems are possible by using the mesh analysis now. In the next class you can see the questions by using the different theorems also now. Understand now? Okay, thank you.